Welcome back. Many of the concepts of a physical network apply to cloud-based networks as well. In the cloud, much of the complexity of setting up a network has been abstracted without sacrificing control, security, and usability. This video will introduce Amazon Virtual Private Cloud, or Amazon VPC. Amazon Virtual Private Cloud is a service that lets you provision a logically isolated section of the AWS cloud called VPC. It is your very own private space in the AWS cloud. You land virtual machines and other resources inside a VPC. Amazon VPC gives you control over your virtual networking resources, including the selection of your own IP address range, the creation of subnets, the configuration of route tables, and the creation of network gateways. You can use both IPv4 and IPv6 in your VPC for secure access to resources and applications. You can also customize the network configuration for your VPC. For example, you can subdivide your VPC into subnets and create a public subnet for your web servers that can access the public internet. You can place your backend systems, such as database or application servers, in a private subnet with no public internet access at all. Finally, you can use multiple layers of security, including security groups and network access control lists, to help control access to Amazon Elastic Compute Cloud, Amazon EC2 instances in each subnet. Amazon VPC enables you to provision VPCs. A VPC is a virtual network that is logically isolated from other virtual networks in the AWS cloud. A VPC is dedicated to your account. VPCs belong to a single AWS region and can span multiple availability zones. After you create a VPC, you can divide it into one or more subnets. A subnet represents an isolated segment of your VPC with its very own range of IP addresses. Subnets belong to a single availability zone. You can create subnets in different availability zones for high availability. Subnets can be public or private. Public subnets have direct access to the internet, but private subnets do not. IP addresses enable resources in your VPC to communicate with each other, and resources over the internet as well. When you create a VPC, you assign an IPv4 CIDR block, meaning a range of private IPv4 addresses to it. After you create a VPC, you cannot change the address range, so it is important that you choose it carefully. The largest IPv4 CIDR block you can choose is /16, which gives you a total of 65,536 possible addresses. The smallest IPv4 CIDR block is /28, which gives you a total of 16 possible addresses for your VPC. It is important to remember this maximum and minimum blocks that you can actually utilize. They are hard limits, so they cannot be broken. You can associate an IPv6 CIDR block with your VPC and subnets and assign IPv6 addresses as well from that block to resources in your VPC. IPv6 CIDR blocks have a different block size limit. The CIDR block of a subnet can be the same as the CIDR block for a VPC. That means that a subnet can be as large as the entire VPC. But you can also use a subnet with its own CIDR block to subdivide your VPC. This structure enables the definition of multiple subnets. If you create more than one subnet in a VPC, the CIDR blocks of the subnets cannot overlap. You cannot have duplicate IP addresses in the same VPC. When you create a subnet, it requires its own CIDR block. For each CIDR block that you specify, AWS reserves 5 IP addresses within that block, and these addresses are not available for you to use. AWS reserves the following 5 IP addresses for different reasons. The first one is network address. The second one is for VPC local routing and internal communications. The third one is for the domain name system resolution. The fourth one is reserved for future use. And the fifth one is the network broadcast address. For example, suppose that you create a subnet with an IPv4 CIDR block of 10.0.0.0/24. This, in theory, gives you 256 total IP addresses. The subnet has 256 IP addresses, but only 251 are actually available because 5 of them are reserved by AWS. When you create a VPC, every virtual machine in that VPC gets a private IP address automatically. You can also request a public IP address to be assigned to a virtual machine when you create the instance by modifying the subnet's auto-assigned public IP address properties. An elastic IP address is a static public IPv4 address. You can associate an elastic IP address with any instance or network interface for any VPC in your account. With an elastic IP address, you can mask the failure of an instance by rapidly remapping the address to another instance in your VPC. Associating the elastic IP address with the network interface has an advantage over associating it directly with the instance. That means that you can move all of the attributes of the networking interface from one instance to another in the event of a failure in just a single step. Additional costs may apply when you use an elastic IP address, so it is important to release them when you no longer need them. An elastic network interface is a virtual network interface that you can attach or detach from an instance in a VPC. A network interface attribute follows it when it is reattached to another instance. When you move a network interface from one instance to another, network traffic is redirected to the new instance. Each instance in your VPC has a default network interface. That is called the primary network interface. It is assigned a private IPv4 address automatically, and it is within the IPv4 address range of your VPC. You cannot detach a primary network interface from an instance. You can create and attach an additional network interface to any instance in your VPC. The number of network interfaces that you can attach changes by the instance type that you're utilizing. A route table contains a set of rules called routes that directs network traffic to and from your subnet. Each route specifies a destination and a target. The destination is the CIDR block where you want traffic from your subnet to go. The target is the processing resource where the traffic is sent through. By default, every route table that you create contains a local route. This is for internal communications within the VPC. You can customize route tables by adding additional routes. You cannot delete the local route table entry. That is used for internal communications and is steady and unchangeable. Each subnet in your VPC must be associated with a route table. The main route table is the route table that is automatically assigned to your VPC. It controls the routing for all subnets that are not explicitly associated with a custom route table. A subnet can be associated with only one route table at a time, but you can associate multiple subnets to the same route table. That means that the mapping between subnets and route table is a one-to-one mapping, despite the fact that you can use the route table for multiple subnets. Thanks for watching. We'll see you in the next video.